We saw in a previous video how to set up Postgres and PGVector in a Docker container, and then how to use LangChain and OpenAI in order to create embeddings from text and store those in the vector database in PostgreSQL. In this video we're going to go a step further. We're going to see how we can integrate that PGVector vector database with Django. We're going to see how to create the connection to the Postgres database that has the PGVector extension enabled, and we're going to see how to integrate that vector data type that's provided by PGVector into our Django models, so we can provide a field that's called a vector field that enables us to work with those vectors. We're going to see how to query the database and pull out the embeddings from that table, and we're going to see how to create a distance metric between all of those embeddings and a given embedding that we've created, and then we can find the most similar items in the table, and that can allow us to create something that's like a very basic search engine that we can then use in our Django applications, and the search is based on the vector comparison that we're doing in PGVector. So let's get started. Now we're going to make use of this library here. It's called PGVector Python. This is a Python library for PGVector support, and specifically if we scroll down to the README here, there is a module for working with Django. We're going to use that in this video in order to integrate Django with the PGVector extension. Now to start with, we need to start up a PostgreSQL server. Now in the last video we did that using a Docker container, and the container we used was the PGVector container, which you can find a link to in the description, or you can watch the last video if you want to learn how to get started with that. If we go to the terminal and we run the docker ps command, you can see at the moment we don't have any Docker containers running, but if you chain the -a flag onto that, you get all of the containers that are on your system, and this is the one here that we used in the last video, and that contains the data that we loaded in the last video. So we're going to start this container by copying the ID of the container, and we can run docker start and pass that container ID. That's then going to start that server, and when we run the docker ps command, you can see now that that PostgreSQL server with the PGVector extension is now running. And we can go to pgadmin, which is a tool for inspecting Postgres databases, and we can see we have the database here, and this is the table that contains the embeddings from the last video. In this video we're going to integrate Django models with this particular table and with the vector data type, and we're then going to see how we can query this table and find similar records to a particular query that the user has inputted in the Django front end. So let's get started. I have a Django application opened in VS Code. This is a very simple application. It contains one view here called index, which simply renders a template called index.html, and we have a URL for that view as well. Now what we want to do to start with is connect to this PostgreSQL database containing the embedding table. So what we're going to do is go to settings.py, and I'm going to scroll down to the Django databases setting, which you can find here. And by default what this does is it creates and connects to a local SQLite database file. We're going to change that, and we're going to connect to a Postgres database server, and that's the one we've got running in Docker. So to start with, we're going to change the database engine that we're using, and we're going to use a PostgreSQL database engine. Now in order to do that, we're going to need to install a particular driver here. So at the bottom on the terminal, we're going to install the Python driver for PostgreSQL. 𝗖𝗵𝗽𝗀𝗲𝗏 binary is what I'm going to install here, and while we're at it, I'm going to also install this library here, the one that lets us interact with PGVector from the Python application. So let's copy that and bring that into the terminal, and we'll run that pip install command to install these in the environment. Once those are installed, we need to change the settings that we're using here to connect to the database. So the name of this database that we're connecting to is vector_db, and that matches what we have if we look at the pgadmin interface. The name of this database is vectordb, so that's what we're going to connect to, and we also need some additional arguments or additional keys and values in this dictionary. So to start with, let's add a user here. The user that we used in the last video for the docker run command was Postgres, and we also need to provide a password here, and that's going to be the password of test. And finally, we need to provide both a host, which is just going to be localhost, and a port number, which in the case of Postgres is going to be 5432 by default. So that's the settings to connect to our Postgres database running in the container. What we're going to do now on the terminal is run the python manage.py run server command, and that has started up successfully, which means that the connection to this database has been established, and we're now ready to develop against that database in the application. So what we're going to do now is go to models.py. All we have at the moment is the import of the models module. So what we're going to do now is we're going to create models that match the database schema that we have for these two tables that were created by LangChain in the previous video. So this is an existing database and we want to connect Django to that database. What we can do is we can either write these models from scratch with all of the columns in these tables along with their data types. We can try doing that, but that's a lot of labor intensive work. What we can also do is use a command in Django called inspectdb. Now I've got a page open here in the documentation. This is about how to integrate Django with a legacy database, but you can use this command that we're going to see in order to integrate Django with an existing database and generate models automatically from the schema in that database. So if we scroll down on this documentation, you can see the command here is called inspectdb. This is built into Django, and we can then output the models that are generated by that command into a file, for example, into a models.py file. So let's copy this command here, and we're going to paste that into our terminal on VS Code. We're going to stop the Django development server, paste that in, and then we are going to run that command. And you can see at the bottom here, this has generated a models.py file. I'm going to move that into the core application where it should be. And once we've done that, we can go to models.py and you can see this auto-generated Django model module. So what this is doing is it's inspecting the database that we have here in settings, and by default that database will be the default one that's in this dictionary. And what it's doing is it's inspecting those tables and generating the column names and also the data types, and it's mapping them to Django field types, for example the UUID field for that UUID column and the car field for the name column. If we scroll down, we get the LangChain PG embedding model. And this is the model that's generated from this table here. It has a UUID, it has collection ID, embedding, and so on. If we go back to the model, you can see these are represented as fields on this model, but there are some things that we are going to have to change here from this model. For example, the embedding field, which is currently a text field, we're going to change that to be a vector field that's coming from the PGVector library that we just installed. So let's go back to this PGVector library's documentation, and we're going to scroll down to the Django section. And it's this section here on adding a vector field to a model. This is what we're going to do essentially. We're going to import the vector field from pgvector.django, and we're going to add that as a field on our model. So let's bring the import into VS Code, and we're going to import that at the top of models.py. And once we've got that, we can copy the name of the field, and we're going to replace the embedding field here with a vector field from this library, and we can remove the blank equals true and null equals true, but we do need to pass an argument of dimensions here, and the dimensions refers to the number of floating point numbers that we have in the embedding column. So each row in this table has an embedding column, and every entry in that embedding column is a vector consisting of a certain number of floating point numbers, and that's the dimensionality of the vector. So the question is, how many numbers do we have in the vectors that are in this column? Well, these vectors were generated in the last video by calling OpenAI's embedding model, and we did that via an API. And if we go to the documentation for embeddings on the OpenAI website, which I'll link below the video, we can see the dimensionality that we got back by scrolling down, and it was this second generation embedding model that we used called Text Embedding Ada 2. And you can see that for that model, the output dimensionality was 1536 dimensions, so 1536 numbers in that vector. What we can now do is go back to the models.py file, and we can paste that in here. So now the embedding field is a vector field, and it has 1536 dimensions. What we can now do is attempt to make the migrations so that Django knows about this file, and you can see we're getting an error. The source code string cannot contain null bytes, and the reason for this is that the encoding of this file that was returned by the inspectdb command is UTF-16. We can then save this with a different encoding, and that's going to be UTF-8, and then we'll save the file and rerun the make migrations command, and you can see it's created these migrations. And if we go to the migrations file, you can see that initial migration. Now, something important to note about this process: when you run Django's inspectdb command, what you get back are the models that are the best representation that Django can generate from that particular database schema, but these are not managed tables. And that means that when you run the Django migrations, these tables are going to be ignored. Any changes to them are not going to be put into the underlying database. So this is an option in the Django model meta class. If you set managed equal to false, It's basically going to tell Django that we're not wanting to manage this particular model with Django's migrations. So that's just something to note there. What we can also do is run the migrate command, and that is going to generate all of the default Django tables from the different packages that are included with Django, like the auth package. So now if we go back to pgadmin and we refresh this tables section here, we now get more tables in the database. For example, the auth user table for the Django user model. But at the bottom, we still have those collection and embedding tables that we're going to work with in this video. So now that we have the setup and we have this vector field in our Django model, let's now see how to use the model in a Django application and how to use this vector field. I'm going to copy the name of this model and we're going to go over to views.py. And at the top from core.models, I'm going to import that model. And in the view function, what we're going to do is we're going to set up a variable called embeddings. And that's going to be equal to that model there. And we're going to use the .objects.all method to get all of those rows from the database. We can then add those rows to the context dictionary with a key of embeddings. And we're going to pass them in, and then they become available, these embeddings, in the index.html template. So if we go to that template, we simply have an h1 tag and a paragraph tag at the moment. What we're going to do is remove the paragraph tag, and we're going to create a template for loop, and we're going to say for every embedding in those embeddings that we are passing into the context, let's output the embedding document. So we'll use embedding.document there, and underneath that we're going to use a pre-tag, and we're going to output the embedding.embedding. Now let's explain what these refer to. So the embedding.document, if we go back to models.py, this refers to the document field on this embedding model, and the embedding.embedding just refers to the vector field that we have here. That's the numbers that are representative of that text that have been generated by OpenAI and then stored in the database in the last video. So let's now run the Django development server, and we're going to go back to the browser, and this is the page that we get here. We get every embeddings document, that's the raw chunk that was embedded using OpenAI, and below that we get the actual vector that was generated, but we are getting it in a truncated format because it is too big to display on the page essentially. So we only get some of the numbers, but we are getting this chunk and vector combination for all chunks that are stored in this LangChain PG embedding table. So let's now build a small application with Django that lets the user enter a query and then lets the user submit that to the back end, and Django will then create an embedding from that query and then find the most similar chunk in the database to that text. So let's get started doing that. If we go back to our application, we're going to go to index.html, which is the template that we're working with. And at the top here, we have the h1 tag. Underneath that, I'm going to paste a div here, and we're going to reference a form in this div. We're going to create a form rather, and that's going to have a method of post. So when we send or submit this form to the server, it's going to send a post request to Django where we can handle that form on the back end. Now when we're sending a post request, we also need to embed the CSRF token in that request, so we'll add that template tag there. And just below that, I'm going to paste some HTML in here. We are creating a div again with a class of form group, and then there's a label, simply says enter text, and then we have a text area, and that has an ID of input text and a name of input text as well. So this text area will allow the user to enter text, and then it's going to send it to the server with this name of input text. And also note that I do have Bootstrap installed in this application, so that is where these classes are coming from. And finally, in this form, we just need to add a submit button, so we can add that just below the div here. Let's save this template and go back to the page. At the top, underneath the heading, we should now see this box here allowing the user to enter some text and submit that to the server. We don't currently have a method of handling this on the server, so if we go to our views.py file, the index view here is just going to pull the objects from the database and return the template. We have nothing set up to actually handle the submission of a post request. So what I'm going to do is set up a method here, or rather reference the request.method and check if it's a post request, and if it is a post request, we can then get the data that's been submitted in that form. So I'm going to create a variable here called text, and we're going to look at the data that's been submitted in that post request, and we can get the field that's been submitted with that particular name of input text, and that matches what we have here in this text area. It has a name of input text, and that's what we're referencing here in this dictionary of the post data. Now at this stage, I just want to print this text to the terminal, and we can test this out. If we go back to the page and we actually submit this to the server, when we go back to our Django application, you can see that text has been received on the server and printed to the terminal. So this is working so far, but what we want to do here is actually take the text and create an embedding from that text. So in order to do that, I'm going to create a new module in this Django application to handle embedding that text. So let's create a new file under the core application, and it's going to be called embedding.py. So in this file, let's create a function called getEmbedding, and that's going to take as an argument that text that's been passed in from the front end. And what we're going to do is we're going to call the OpenAI embedding model, and we're going to do that by sending a request to OpenAI's API. That's going to take this text here and it's going to convert it to a vector and return that vector to us. So let's go back to the OpenAI documentation for embeddings, and you can see at the top here the section on how to get embeddings. To get an embedding, you send your text string to the embeddings API endpoint along with a choice of the embedding model ID, and this is the default here. It's the text embedding ADA model. So when you send that request, your response will contain the embedding or the vector, which you can extract, save and use. And if we scroll down, you can see an example response here. It contains a top level key called data, and if we go into that data array, you get back the embeddings for all the text that you've submitted. Now, in order to get this working, what we need to do is install the OpenAI library to allow us to communicate with their APIs. So let's go back to the terminal, and we're going to stop the server and run pip install, and we're going to install the OpenAI library. And as well as OpenAI, we also need to install another library, and that's the tokenizer that OpenAI have created. It's called TickToken. We can also install that into our environment. And then at the top of this file, what we're going to do is we're going to import the OpenAI library, and that's going to allow us to call this embedding endpoint as we're about to see. So I'm going to now set up a constant in this module. It's called embedding model. And this is the model that we're going to use, the text embedding ADA version 2 model. And then within the body of the function, I'm going to take the text that was passed in as an argument, and we're going to replace the new line characters with a space in this case. And that's because these embedding models tend to work better if they don't have these new line characters and they're replaced, in this case, by a space. So we remove the new line characters and reassign that result back to the variable text. We're then going to create a variable called response, and we're going to use the OpenAI module that we've imported at the top, and that has an embedding object, and that has a static function called create. And this is going to create an embedding for a piece of text that we pass as an input here. So let's pass our text as an input, and note that we are using a Python list with a single element, and that element is the text that was passed in and then had its new lines replaced by spaces. And I'm going to bring these parameters onto new lines so we can see them a little bit better here. As well as the input, we can also pass the model that we want to use to embed the text, and we're going to set that to the embedding model that we set up here on line 3, and that's the ADA version 2 model. And the final thing we need to set here, because we're calling the OpenAI APIs, we need to set the API key, and we're going to set that to something that we have in the Django settings module. So if we go to settings.py, I'm going to scroll to the very bottom here, and I've got this variable called OpenAI API key. Now you can see that we've hard coded this in settings.py. Don't do this in a real application. You would want to load this in from an environment variable. But for simplicity, I have this here, and obviously the value is obscured. But what we can do in our embedding.py file is from the django.conf module, we can import the settings, and then for this API key parameter, we can use settings, and we're going to copy the name of the setting here. It's OpenAI API key. So let's print that response out to the terminal, and we can see what we get back from the OpenAI API. But just to go over this one more time, we're setting up an embedding model, a reference to the ADA version 2 model, and then we're taking the text that's passed into this function, we're replacing the new lines with spaces, and then we're passing that text to the OpenAI embedding.create function, which is going to create an embedding or a vector from that text. So this is our embedding function. We're going to add a return statement and actually extract the vector in a second. But for now, let's go back to views.py, and I'm going to import this function at the top here from the core.embedding module. We import getEmbedding, and what we're going to do is simply call getEmbedding here and pass the text into that. And hopefully we're going to see that printed on the terminal when we run the Django development server and we submit this post request containing a query. So let's go back to our application now. And I'm going to submit a query here, just a random query. And if we go back to the terminal here, you can see we get back a response that contains this embedding here, this long list of numbers. So what we're going to do is go back to embedding.py, and we're going to return that particular number, that vector, to the caller. Now in order to do that, we need to take the response, and we need to index into that dictionary at a particular key in order to get the embedding. If we go back to the documentation for OpenAI embeddings, the top level key is data, so let's copy that, and we're going to index in here at data. If we go back again, you can see we have with the data a list here, and we're going to index in at element 0 in this list and get the embedding key within that. So let's go back to embedding.py. We're going to index in at 0 here, and finally we can get the embedding value from that particular object at index 0. And I'm also going to remove this print statement. So we're returning the vector here, and that's actually going to be a NumPy array. So PGVector under the hood, when it's pulling out these vectors from that particular column in PostgreSQL, it's going to convert those to NumPy arrays as we're about to see. So let's go back to views.py, and now we're returning something from this function. Let's store that in a variable called embedding. And now we can print the embedding to the terminal, and we're going to see if that works. And if it does work, what we're going to do next is we're going to query the database with PGVector and find the most similar vector and the most similar document to the query that we're about to submit. So let's go back to the page, and I'm going to submit a random piece of text here. Once we do that, if we go back to the terminal, you can see we get back the embedding vector below. So now we have that vector. The question is, how do we submit a real query and check what is the most similar document that we have in our vector database? How do we use PGVector and its similarity and distance metrics in order to find the most similar document and most similar vector to what we have here in this embedding? So let's remove the print statement here, and what I'm going to do is go back to the PGVector documentation. Now we have here an example of getting the nearest neighbor to a vector. So what we do is we import the L2 distance metric, and we use that metric in the item.objects.orderBy function. So we're ordering by the L2 distance in the embedding column from whatever value is in that column and the vector that we pass in here. And that's going to return to us a query set of objects, and the objects at the beginning of that query set are going to be most similar based on this vector here that's passed in to this L2 distance metric. And the PGVector extension has other metrics as well. We also have the max inner product and the cosine distance as well. So let's copy this import of L2 distance, and we're going to go back to views.py and import that at the top. And we're going to take the model LangChain PG embedding here. This represents the table that contains our vectors and our documents from that text that we chunked in the last video. And what we're going to do is we're going to use the .objects.orderBy function, and we're going to order by that L2 distance that we've imported, and the column is called embedding. That's the name of the field on this model. It's the name of the column in the underlying table, and the vector that we want to compare all of these embeddings to is this one that we extracted on line 13 above from our custom get embedding function. So we're going to pass that in as the second argument to the L2 distance. So again, what this is doing is it's taking all of the rows in the LangChain PG embedding table, and it's calculating the L2 distance between the embeddings in those rows and this particular vector that we've got back from the OpenAI embedding model, and it's going to order the results by the documents and vectors that are closest to that embedding that we're passing in. So to get the most similar document, we can also chain another Django function, the .first function, and that's going to give us back the object that's most similar to the text that's passed in with this embedding. So let's store the result of that in a variable called document, and I'm also going to clean this query up a little. So now we can see we're ordering by the L2 distance between the embedding column and this embedding that we've extracted, and because this is a distance metric, when we get the first value in that query set that's ordered, what we're getting is the item with the closest distance to this vector here. So I hope that makes sense. What we're going to do now is create a context dictionary, and this is going to contain two keys. Firstly, the text that was originally submitted by the user. That's the text that we extracted from the post request. And secondly, I'm going to create a key here called most similar, and that's going to be equal to that document that we've got back from the database on line 14. And finally, I'm going to return the render function, and I'm going to render a new template here. If we look at the left hand side, I have a template called results.html, so I'm going to put that in here, and we're going to pass the context to that template, and now we can save the views.py file. What I'm going to do is go to results.html, and I have a skeleton template here. We have an h1 tag with the header results, and then we have two sections below that, one containing the original text that was submitted in our query, and the second h3 tag contains the most similar document that was found when we queried the database using that L2 distance metric from PGVector. So what we're going to do underneath the original text header is create a paragraph tag, and we're going to enter that text that was originally submitted from the form, and I'm going to copy that just below here to the most similar document, and I'm going to replace the key of text. I think we called that most similar in the context, and what we're going to put out here is the document. Now remember, most similar refers to one of these embedding models here, the LangChain PG embedding model, that contains the document, the original document that was vectorized in the last video. So we're going to refer to the .document field on that model when we output this in the result template. So that's everything we need, and this is going to act kind of like a small search engine where we take some original text that was submitted and we get back the most similar document from our vector database based on the vector representation and the distances between those vectors that has been calculated by PGVector. So what we can do is save this, and I'm going to go back to our list page here, and I'm going to do a bit of searching just for one of these queries. If we look at inflation, you can see that that's mentioned a few times. So if we scroll back up to the top, I'm going to input a query here. How do we build a better America to fight inflation? Let's submit this and see if it works. It's going to embed that original text and create a most similar document from that. And you can see the document below here. You can see phrases here like, I call it building a better America, my plan to fight inflation, and so on. So this process looks like it's found a good match in terms of the documents that are in our vector database, something that matches closely with this query that we've sent to the back end. And the mechanism for finding these similar documents is quite simple when you look at this code here. All we're doing is we're taking the submitted text, we're calling OpenAI's embedding model via this function here and getting back an embedding, and then we query the database using the PGVector L2 distance metric to calculate the distance between all of the rows in that database and the embedding that we're passing in. We order the results so that the smallest distance is first in the query set, and we extract that model which represents essentially the most similar document to our query. And all we're doing below that is passing the original text and the most similar document into a context and rendering them into this results.html template. So one last thing to show in this video, what if we want to insert data, including the vectors, into the database? Now in order to demonstrate how to insert this data into the database, we don't need this code here that pulls out any objects from the database. We just need to take the embedding that we're getting back, and now we need to insert that embedding and that original text into the database. So if we look at models.py, what we have is an embedding and a document. These are the fields that match the data that we have in our view. For example, the original text will be the document and the embedding will be the vector field. So what we're going to do is we're going to go to the next line, and I'm going to use the LangChain PG embedding model, and we're going to use the .objects.create method in order to create a new row in this particular table. And for the embedding field, we're going to add that embedding that we've pulled out from this get embedding function above. And we also need to add the document as well. That's just going to be the text that the user has submitted from the front end. And there's one final thing we also need to add. If we go back to models.py, the primary key is a models.uuid field. So what I'm going to do is go back to views.py, scroll to the top here, and we're going to import the uuid module from Python. And then we can go back down to the create function, and I'm going to add the uuid keyword argument here, and we're going to reference that module's uuid4 function, call that function. That's going to generate a uuid that we can use as the primary key for this new row. So we're calling the objects.create function, and we're passing in the uuid, the embedding, and the document. And what we're going to do is store the result of that in an embedding model variable. And what we can then do below that is print the embedding model's primary key after it's been created in the database. And that primary key will appear on the terminal, and we're going to then be able to query that primary key in pgadmin, and we can see what's been loaded into that table. So let's save this and go back to our front end. We're going to go back to the index page that we had here containing the form, and I'm going to input the same query here. How do we build a better America to fight inflation? We submit that, we're redirected to the page, and if we go back to the terminal, you can see the UUID of the object that's been created in the database. So let's copy that, and we're going to go to pgadmin now, and I'm going to go to the query tool on pgadmin. This allows you to issue an SQL query And the query that we're going to execute here, we're going to select all from that PG embedding table, the LangChain PG embedding table. And we're going to issue a where clause here, and we're going to check the UUID column, which is the primary key in this table. And we're going to check that that's equal to the UUID that we have in the terminal here. So let's copy this UUID, and we're going to go back to pgadmin and paste it in here. If we then execute this query, we get back this row here that has that primary key that is equal to the UUID, and you can see the embedding that we have from the text that was submitted. This is the embedding created by OpenAI's ADA embedding model. It's been stored in Postgres in this embedding column here, which is created by PGVector. And if we scroll to the right hand side here, you can see we have the document as well, and that document matches what the user typed on the front end. It was the query about how to build a better America to fight inflation. So that sums up everything I wanted to cover in this video. Let's do a quick summary now. If we go back to models.py, we've seen how to create a vector field on a Django model, and we've also seen in views.py how to actually create a new instance or a new row in the database that contains a vector. We also saw how to build a small search engine type app where we let the user enter a query, we vectorized that query or embedded it using OpenAI, and then compared the embedding to all of the embeddings in the database to find the most similar. And we used the L2 metric to do that. Again, that comes from PGVector. And I want to finish, if you're interested, with a small discussion on things that you could do with this particular utility with vector databases and web applications. If you're interested in any of these, let me know in the comments and I'll try and build some of these in the future. But an example again to extend what we have here would be you could embed all sorts of news articles into a vector database and then use this particular model here as a search engine or a recommendation engine for finding similar and relevant articles to user queries. And generally speaking, you can use this type of thing to extract the most relevant pieces of text from any document in response to a user query. And this type of approach could be used in specialized text, for example, legal, medical texts and scientific texts. If you create text embeddings from that content and store them in a vector database, you can then use that vector database to search for similarity and essentially use it as a search engine again or recommendation engine and find relevant pieces of specialized content. And because under the hood all of this is stored using vectors, these are amenable to machine learning applications as well, or deep learning applications that use vectors as inputs, and that opens the door to all sorts of different applications. And finally, you could also perform things like dimensionality reduction on these vectors. Now this is a 1536 dimensional vector, so it's impossible for us to visualize these vectors in any kind of geometric space because the dimensionality is just too high, and in fact that's impossible if we go beyond 2 or 3 dimensions. It's very difficult to visualize vectors, but what you can do is reduce the dimensionality, and that's essentially a compression technique that reduces these vectors from, in this case, 1536 dimensions down to 2 or 3 dimensions. And when you do that, you can then plot these using something like matplotlib, and that can often reveal clusters in your data, and it can even allow you to find hidden relationships between certain types of objects based on those clustering techniques. So in order to reduce the dimensionality, you can use things like principal component analysis, PCA, or you could use a technique that is called 𝗖𝗍, which is T-distributed stochastic neighbor embedding. And that's something I don't know much about, but scikit-learn does have a 𝗖𝗍 module that you can use in order to reduce the dimensionality of your vectors and then plot them and visualize them using matplotlib and other tools. If you're interested in any of those approaches, let me know in the comments. And remember as well, we're using Django here, but we can plug any backend we want in front of this vector database. But with the Django module built into this PGVector Python extension, it works nicely with Django. But if we scroll up here, we can see we also have integrations for 𝗖𝗵𝗽𝗀 and SQL Model. So this will also work well if you're using Flask or FastAPI. So that's all for this video. We've seen how to integrate Django with PGVector and PostgreSQL in order to create applications that use vectors and embeddings. And we've seen how we can take a user query, embed that into a vector, and then find similar items from the database. If you've enjoyed this video, please like and subscribe to the channel, and we'll see you in the next video.